But now we get into the question of, okay, now it's time to create some mocks for this. Same as last time, right? If we want to run our script, if we want to run our code completely on an Anvil chain from scratch and not even on a forked testnet, we're going to need a couple different contracts. What are we going to need? We're going to need a VRF coordinator at the very least. So how can we deploy our own VRF coordinator? Let's go ahead and scroll up and let's click into this. And we can go into our lib folder, Chainlink Browning contracts, SRC 0.8, and we can look for this VRF code in here or look for some mocks. And in fact, there's actually a mocks folder in here called VRF coordinator v2 mock, and we can just use this directly in our tests as opposed to writing one ourselves. Chainlink VRF already has one for us. Perfect. So let's go ahead and just use this VRF coordinator v2 mock in here. So we're gonna have to deploy this mock. So we're gonna actually import it in the top. We're gonna say import at Chainlink /contracts. Oops, excuse me. Import VRF coordinator v2 mock from at Chainlink /contracts. Where's this located? Chainlink contracts SRC v0.8. Oops. SRC v0.8 /mocks /VRF coordinator v2 mock.sol. And so now what we can do is we can deploy this with a vm.start broadcast. Remember, we need this vm.start broadcast to actually deploy to any network. And I always like to do vm.stop broadcast right afterwards. And we can say VRF coordinator v2 mock, VRF coordinator mock equals new VRF coordinator v2 mock. And let's go see what the constructor parameters are. Constructor, it needs a base fee and a gas price link. So for Chainlink VRF, it gets paid in Chainlink tokens. Whenever you request a random number from your subscription, it gets paid in Link tokens. So it has two payment parameters. The base fee is a flat fee it takes, and the gas price link is how much link it gets paid for each additional piece of gas that you use. When the Chainlink node calls fulfill random words on our contract, the Chainlink node is the one actually paying the gas to do so. And so it gets reimbursed in link for that gas cost based off of this gas price link parameter here. So in our helper config, we could just default those to uint 96 base fee, which is equal to 0.25 ether, which is really 0.25 link, right? Or uint 96, excuse me, and uint96 gas price link, which is going to equal to 1 E9, real small link per gas, which is just going to be like 1 GWE of link really. So we'll take this base fee, gas price link like this. And then now at the bottom, we can return all of our good stuff here. So we'll do return network config, same setup here. So the entrance fee, let's actually just copy this whole thing and just adjust it as needed. 0.1 ether, that's cool. Interval 30, that's cool. VRF coordinator, now this is going to be the address of the VRF coordinator mock. Gas lane doesn't matter, so we can leave it like this. Subscription ID will matter, but our script will add this. And let's keep 500,000 gas here. So this is actually gonna be real similar to our Sepolia, really with the only main difference is this VRF coordinator mock is different. And oh, sorry, this could actually be a pure function instead of a view function. But this one has to be neither because we actually send a transaction. Okay, cool. So now we have a Sepolia config and an Anvil config with our mocks in here. Badass, very nice.